Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a full stack Ethereum Dapp. Alright, so in this video we're going to continue on with our progress and actually build out the smart contract that we started in the last video. Alright, so before we get into that, be sure to subscribe to this channel if you haven't already. Click the like button down below. And as always, if you want to learn how to become a highly paid blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, so in this video, we're going to continue on with the progress that we made in the last video where we set everything up, right? We connected to the blockchain. We created this basic smart contract here, this marketplace smart contract, and we wrote a basic test, all right? So you can find the code at this point in the video with the link down in the description below. But yeah, let's continue on with this marketplace smart contract, and we'll continue writing tests alongside it as we develop it, right? So first things first, make sure you have all your dependencies installed with npm install, all right? And also make sure that you have Ganache running, right? This is your development blockchain. Okay, all right, so let's continue on. The first thing we want to do with this smart contract in this video is actually create a way to add items to the marketplace or products, okay? We want to basically create a product as a seller, right? We want to list a product. So in order to do that, we need to model the product in some way, okay? So I'm going to do that in Solidity with something called a struct. So Solidity allows you to create your own data structures like this, so say struct, and we'll just call it a product. Okay, and we can really give this any kind of attribute that we want to, okay? So the first thing I'm going to do is give this struct an ID, say uint ID, all right? So uint stands for unsigned integer. That basically just means that it can be a number without a minus sign in front of it. It has to be positive. You know, a sign is a minus or a plus, and this is always going to be positive. Okay, so we'll say a string name. String's pretty self-explanatory, just like this. And we'll also give it a price, say uint price, all right? And then we'll give it an address of the owner. All right, so this is going to be the person who owns the product, and when we're listing it, it's going to be the product seller, but whenever it's purchased, this is actually going to change to the new owner, which will be the buyer, okay? So then we'll also have Boolean for purchased, to see whether the product has already been purchased in the marketplace or not. All right, so this is how we're going to model the product. We just create this basic struct that gives it these attributes. All right, so now we need a place to put this newly created structure. So also I'll mention this is just a description of how a product works. It's not necessarily an individual product. Each newly created product will follow this pattern, all right? So anytime we create a new product, we need a place to put them, and we're going to use something called a mapping in Solidity, all right? And we'll create the new mapping like this. We'll use the mapping keyword, mapping, and so essentially a mapping is a key value relationship. So it's like a hash table or an associative array or a hash or an object in other languages where basically we have a key and a value. So in this case, the key is going to be the product ID, all right? And then the value is going to be just this whole product struct like this. So the ID is going to be an unsigned integer like we declared here. So we'll show the key value relationship like this. We'll say uint. And then we'll pass in the value, which will be a product. And then we'll call this products. All right. So now we have our syntax highlighting back. All right. So basically, here's the mapping, right, that we've declared. The key is an unsigned integer, which will be an ID. And then the value will be a product data type, which we created here when we created this struct. Okay. This can be products mapping is the name of it. Now we want to be able to access this products mapping outside of the smart contract, not just inside of it. So we'll call it public, just like we did with the name. So public. All right. So there you go. Now we have a place to put these products. Okay. So also, we need a way to know how many products exist inside this mapping. So you could have this giant, lookup with IDs and products like we did here. But the problem with Solidity is you really have no way of knowing how big this mapping is. It's just a limitation of the EVM. So basically, if you created a product and you only had 5, you don't know that there's only 5 inside of here. If you looked for product 5, it would return a product, but if you looked for product 6, it would just return a blank struct with default values, which would be like 0, empty string, 0, 0x0, and false. So we need a way to know how many products are inside of here, because whenever we list them out, we want to know how many there are and actually get them one by one. All right, so we'll do that like this. We'll create a counter cache. We'll say uint public, just like everything else, and say product count. All right. So that's going to be something that we can use to know how many products exist inside this mapping. We'll just increment this anytime we add a new product. We'll increase it by 1. All right. So we can use a default value right now. We can say equals 0. All right. So there we go. We've got a way to describe a product and put it on the blockchain. That's another thing I'll mention. This mapping is a state variable. So anytime we add new products here, they're getting put on the blockchain when they're inserted into this mapping. And when we read them out of the mapping, they're getting read from the blockchain. Okay, same thing with this product count. All right, so now that we have a way to put them on the blockchain, let's actually do it. So we're going to create a new function called create product. We'll do it like this. We'll say function create product. All right. And we're going to pass in some values, and then we'll put it inside of here. All right. But I'm going to fill this out. Let's actually write some tests as we do this. So I'm going to open up a new column and put the tests over here and the Solidity source code on one side. All right. So inside of here, basically what we want to do is a few things. We want to, create the product. We want to trigger an event, basically tell the blockchain that something happened. And we also want to make sure that the product is correct before we do it. Make sure parameters are correct. So basically, we're going to accept some parameters inside this function. We want to make sure that they're correct before we create the product. We want to create it, and then we want to trigger the event. All right. So that's 3 things that we'll do. And we'll write tests to check for this, okay? So first, what I'll do is create a test over here. We'll say, give ourselves some space just so we can see. Just like describe deployment, we'll do this. We'll say, we'll just copy and paste. We'll say describe products. And we're going to take this out. I'm going to copy this before filter, before hook, and I'm going to paste it like this just so that I'm not, writing code a bunch of times. And inside of here, I'm going to create the product first, okay? So let's just say let result product count. So I'm going to basically create some variables here that we'll update later, but inside of here, I'm going to say result. And then I want to basically just say await. We've already got marketplace, so I'll do it like this. I'll say create product. All right. So that's going to create the product first, and then we're just going to test. Let's just make sure that it actually incremented the product count to 1. So say creates products. All right, so let's take out all this. So I did this kind of fast, but I basically wanted to show you what I'm checking for. So what we want to do is basically, well, actually we need to fetch the product count. So let's do it like this. Let's do that like this. So we'll say results, we'll say product count. All right. So I know I did that kind of fast, but let me just go over what I did. So we said describe products. And like I said, you can download this source code, or you can just pause this point in the video and try to digest some of this code. So for products, we want to just make sure that it creates a product. We're going to fill this out more, but at first, we basically just want to say the product count changed whenever we added a new one, okay? And we just created product count over here, and we want it to go from 0 to 1, all right? And before we actually check for this, we're going to, try to call the create product function, which is we're going to fill out right here, right? We're going to add some arguments inside of here. So we can say create product, and we could go ahead and just increment that value. Let's go ahead and do that. All right, so let's say product count. So let's say increment product count. Do that here. Say product count plus plus. All right, so let's run this test. Should work. All right, so while that's running, basically we're going to check for the product count, and then next we're going to accept some arguments inside of here, right? This is going to be what we actually, we're going to say we want to create a product with a few attributes. So we can say string memory name. The product's going to have a name, right? We're going to set this, and we're going to set the price as well. All right, and then say uint price. Okay, I'm gonna go back and do this as one tab for a second, just so you can see the code. And we'll also call this public, so that we can call it. I think we're not going to be able to do that. Our test is going to fail. All right, yeah. So we got an issue here. Sorry guys, let's just continue on with this, and we'll increment the count as we go. All right, so memory name uint price public. All right, so we want to accept some arguments. We want to make sure it just increments the count first. Okay, so we'll set all these here in a minute, but let's just fix the problem that we have. Let's see here. Let's see, you got parsing marketplace sold expected that. Oh, I see. I didn't add a semicolon, so we could try to run this again. Let's just take these out, but leave public, right? You need public in order to be able to call this function. So save that, rerun it, triple test. I'll just wait instead of continuing on. All right, it worked. So it actually incremented the product count, okay? So now let's continue on building this out. I'm gonna put these back in here. So basically string memory name, all right? And then uint price, okay? And we're just gonna increment the product count like that. So let's go over here and add this. So we'll create a name. We'll just say iPhone X. And as a price, we're going to specify this in terms of Ether, all right? So I'll explain that. Basically, the price, we're gonna purchase, items from the marketplace with Ethereum cryptocurrency or Ether, okay? So the price is gonna be expressed in Ether. So, but whenever we store, Ether on the blockchain, we store it in something called Wei. All right, so Wei is basically the smallest denomination of Ether. You can go to this website, etherconverter.online, to see the different values of Ether. So if you subdivide Ether smaller and smaller and smaller, you eventually get to Wei. It's sort of like Ethereum's penny. It's like a really, really small penny, okay? And we deal with this value. So this is 1 followed by 18 decimal places, which is basically 1 Ether divided by decimal places, all right? You'll see other values like Gwei a lot, right? So we're going to deal with Wei. So how we can do that in our test is basically say we're going to do iPhone X, but we're going to create a product in Wei. So we want to say 1 followed by 18 decimal places. So we want to say 1 Ether, but to store 1 Ether, we have to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 in order to create 1 Wei, or sorry, 1 Ether expressed in Wei. That's what Ether looks like as Wei. And smart contracts always deal in Wei values like this, okay? So I don't want to do that, but that's what it would look like if you wrote it out literally. So I'm going to say web3 utils to Wei, and I'm going to pass in 1, all right, say Ether. And that will convert it for us automatically. All right, so let's go ahead and rerun the test. We didn't change anything inside of the Solidity smart contract necessarily. We just accepted some arguments, and that's what I want to do here. All right. All right, still works just fine. So it's yelling at us that we have some unused function parameters, but that's okay. We're going to use them now. So we'll go back to the smart contract. Let's actually do some stuff. So inside of here, we want to create a new product and add it to the mapping. We'll do that like this. We'll basically just say, after we've incremented the products count, we'll say products, say product count, and we'll say equals. We'll create a new product like this. We'll say product. All right, let's say product count. So we need to give it several attributes. The ID, all right, so in this case, it's just gonna be the product count because we incremented it. All right, see why I'm using this counter cache? Like the counter cache always corresponds to the most recent ID, right? So product count 0, we increment it, it turns into 1, which becomes the ID of the first product, right? And so on and so forth. So product count, and we'll say name, all right, price, all right, which we'll fill out, which we'll get from here. And then also we want to say the owner. So the owner is going to be the person who called this function. And we have access to that inside of Solidity with something called msg.sender. All right, so msg is a global keyword in Solidity, and sender is the value of the person who called the function. This is going to be an Ethereum address like you saw in Ganache, all right? So then we're going to say, is it purchased? And since we just created it, it will not be purchased, so we'll call it false, okay? All right, so that creates a new product. Let's just go ahead and rerun the test to make sure everything's working correctly, and then we will check for that in the test. All right, it passed. So in order to test for the product, I want to make sure that it was actually logged out. Okay, so we can check the logs by triggering events inside of Solidity. All right, this is really helpful. You can use this for a lot of stuff. I want to show you how to use events right now. All right, so we'll first need to define an event. We do that like this. We can say event. We'll capitalize this and say product created. All right, and I'm going to open this up like this. And inside of here, we're going to just pass in all the values from the product. Basically, we'll use kind of these same. So I'm just going to copy them, paste them here. And instead of semicolons, we're going to use commas. And we'll delete the last one. All right, so we got ID, name, price, address of the owner, and also purchased. Okay, so this is how you create a new event inside of Solidity. And we're going to trigger it right here. Kind of the same way we did this. We're just going to emit the event with these values. We'll say emit product created. All right, and I'll pass in the values. Let's actually just copy all these. So do this, pass them in. And now we'll be able to see this logged out whenever we call the function inside of our test, okay? And I'll show you how to do that. Basically, I'll just console log it. We'll go back to our test file, and inside of here, we'll say const event equals results. All right, so result. Actually, let's do this. Before we store it, let's do console log. Result logs. All right, so we'll just check the logs, run the test. And I'll show you what's inside the logs. And we're going to dig into those logs to fetch these values, inside of here. I'll show you how to do that, okay? All right, so it looks like we had a problem here. So let's just fix this. Let's see here, parse contract, expected. Oh, so I forgot a semicolon again. Let's see, where did I do that? All right, so I forgot the semicolon after the event. Sorry, guys. So on line 22, make sure you got a semicolon after you declare the event. We're on the test again. So this is another reason we have tests, to check our errors, make sure that stuff's working properly. All right, so another issue here. I named the event the wrong thing. So I forgot a D. All right, one more time. Sorry, guys. Run the tests again, and this will hopefully pass this time. And we'll be able to see the product logged onto the screen. Okay, so it's passing, and here's what we logged, right? So I logged out the logs from this result that came back whenever we create the product. All right, inside of here, we see some values. We see a result, all right, and it's got some stuff inside of here, right? You see this ID, you got this name, price. All right, so we want to dig into this and pull these values out and check them to make sure that they're correct, that the name is right, that the price is correct, that the owner is correct, all right, all that kind of stuff. So we can fetch that like this. We'll just say const result like this. Say const result equals, const event equals result dot logs, and then we'll get the first one. It's an array, so it's a zero-based index array. We'll get the first one and say args. All right, we just saw that. So here's the args. Okay, args result. So that'd be the event. and we want to dig into those values. So first we want to just say assert equal event.id to number. I want to convert it to a number. Is the same thing as the product count to number. And we'll just say ID is correct. We'll do the same thing. I'm actually going to just copy this. Event dot, say this is correct. Just going to copy this and do it 3 more times. So event dot name is the same thing as let's just do it literally here. We'll say iPhone X. We'll just copy it. So name is correct. And then also event dot price. And I'm going to do this literally as well, just to show you that this converts into way. So we'll say 1 followed by 18 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We'll say price is correct. And then also the owner is correct. And we're going to track the owner, okay? So I'm going to come back to this. I'll show you in a second. So purchased, and we're just going to say false. Purchased is correct. So let's check for the owner. All right. So the owner, let's actually break some of these up. So if you go to the top of your test file here, this just says accounts. All right. This is going to be all the accounts that are injected from Ganache, right? If you pull up Ganache, you'll see all these accounts, right? So you can actually access these individually. Since this is an array, we can break them up like this. And we can say, account 1, account 2, account 3. All right. But I'm actually going to name these accounts. We'll say account 1 is going to be the employer. All right, and then account 2 is going to be the seller. And account 3 is going to be a buyer. All right. So what we want to do here is basically just make sure that the owner is the seller. All right. So in order to do that, we want to basically say that this person who created the product is the same thing as seller, but we need to tell the test that the seller is the one calling this function. And we do that exactly like this. We add some function metadata. So after the normal arguments are passed in, we pass in an object and we say from, and we say seller. All right. And that is exactly how Solidity knows that MSG sender, right, is the seller. So MSG.sender comes from the metadata from the function. And that's exactly what you see here. All right. Okay, so that's a little complicated, but let's save this, run the test, and see if it works. All right, works. So it successfully creates products. All right, so I think that may actually be all we need for this particular part of the tutorial, okay? Well, actually, sorry, that's all we need for the success case. Let's also check for failures, all right? All right, so what we want to do is make sure that a few things are correct. So we want to make sure that the name is there, which will require name. And then we also want to require a price, a valid price. All right, so the first thing we want to do is use these require statements. So we say require, we'll say the name, and we basically want to check for the length that is greater than 0. So essentially you just don't want to be a blank name, right? So basically anything inside of this, if it evaluates to true, this function will continue execution, but if it evaluates to false, it'll stop execution and throw an exception, okay? And, they won't pay any gas or anything like that, okay? So let's say bytes. We actually need to do that. Sorry, bytes name length is greater than 0. That just checks that the string actually has data inside of it. All right. Same thing for price. So say require price is greater than 0. Sorry. 0. And yeah, that'll work. All right. So let's just run the test, make sure it still works. Should be fine. And then we'll test for the failures in a second. And also, while this is happening, I want to make a mention of something. You see these underscore variable names? Basically, I'm using underscores here as a convention to show that these are local variables and not state variables, right? So all the state variables don't have underscores in front of them. It's kind of a convention from other programming languages. I try to use the same thing. You know, for example, we have underscore name here and name here without underscores. So that prevents, you know, conflicts and stuff like that. All right. So that's just something I wanted to mention. Okay. All right. There we go. So now what we can do is actually check for this in the test. We'll just check for failures. But before we do that, we need to import something new into our project, into our test suite here. We're going to use a special chai dependency that we installed inside of our package.json file. It's already there. We're going to use chai as promised, okay, and should. So just add this to the top, all right? So you can pause the video or get this from the source code if you want to. Basically, we're going to require chai. We want to use chai as promised, which is in our package.json file, and we want to use should, okay? So you need this before you continue. So scroll down, go to the failures. The first thing we want to check for is that if we create a product without a name, it's going to mess up. So say a product must have a name. And we'll say await marketplace. Oops, marketplace. Create product. Let's actually just do this. We'll just copy it. All right, let's do this. Marketplace. And let's just take the name out. So no name. And we'll say should be rejected. All right, so that's how you check for the failure. That's why we just imported this stuff, should. So should be rejected. And let's use shuffle test. See if this works. All right, so it was supposed to be rejected, but it was fulfilled. And so what's the issue here? All right. I think I see what happened. So it's funny, I was talking about these local variables. We need to put an underscore here. So we want local variable name, not the global variable name, because name was already set, but this wasn't. So make sure you use your underscore here. It's funny that I just mentioned that and then I messed it up myself. So let's try the test again. Shuffle test, and this should pass this time, but it's good that, you know, we caught our error and we see that our tests are actually working. So that's good. All right, there we go. So now let's check for the failure that it has a price. So go back here and we'll just copy all this. Product must have a price. So we'll put the name back in. We'll say iPhone X is fine. All right, and also we want to just use a blank price. So we'll just say 0. All right, see if this works. All right, and it passes. All right, so that's it for this part of the tutorial series. In the next video, we're going to continue building on our marketplace and allow you to purchase products, okay? Now we've been able to list them, and now someone else can purchase them, and that'll be the final functionality that we create before we start building out the client-side application and use the full stack app, all right? So as always, be sure to subscribe to the channel if you haven't already. Click the like button down below. And if you want to learn how to become a highly paid blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.